Right, so in this video, I will be going over how to do our titrations from the PowerPoint, the example. So here we're starting with a base and we're titrating with an acid. So first off, what is the initial pH? So since we just have base to begin with, let's always write down our chemical equation. CH3, NH2, bases in water, so that's going to be our acid. Mix CH3, NH3 plus OH minus. All right, and so this is more or less an ice table, or this is liquid, so that's not going to count. So Kb equals the concentration of CH3, NH3, and if you do your ice table, that's X. OH minus is X divided by the concentration of CH3 NH2, 0.175, and Kb is 4.4 times 10 to the minus 4. So we need to solve for X. Oh, I'm going to open up Excel to do that. It's 4.4 times 4. Square root that. All right, so X is 0.020976. 20976. That's our hydroxide concentration. So let's find POH by taking the minus log of that. So POH equals 1.68. So pH is 14 minus that. So 12.32. Let me just double check. 12.32. Which makes sense because we start with base, so pH should be above 7. All right. Now, how much acid do I need to reach the equivalency point? So this is a 1-to-1 ratio because we can rewrite what's going to happen when we have our acid, NH2 plus HBr goes to CH3, NH3 plus Br minus. It's a 1-to-1 ratio. So I can use M1V1 equals M2V2. So my base has a molarity of 0.175, and I have 25 mils of it. That equals the molarity of my acid, 0.150, but I don't know how much volume I need. So let's do that calculation. To 5.150. So you need 29.17 milliliters of acid to get to the equivalency point. All right. So our next question is, how about if I just add 5 mils? How much, what's the pH rather? So when you are not dealing with the equivalency point and you're adding some acid to your base or vice versa, adding some base to your acid, you need to change to moles. Because if we look at our chemical equation right here, that is 1 mole plus 1 mole. You can't be in molarity because molarity is moles divided by volume. So you have to be in moles. So the amount of moles I start with of my base, well, I have to convert that from molarity. So there's my molarity, 0.175 moles divided by 1 liter, multiplied by how many liters I have, 0.025. So 0.175 times 0.025. So I have 0.004375 moles of base. How many moles of acid do I have? I do the same calculation, 0.150 moles divided by 1 liter, and I'm adding 5 mils, 0.005. Do that calculation. That's 0.005. I added 0.00075. So 0.00075 moles acid. All right, so going back to my equation, I started here with 0.004375. I added 0.00075. All right, these react completely. So that means I just made 0.00075 of my conjugate acid here, right? CH3NH2 plus HBr makes my conjugate acid. So after adding that acid, HBr will react completely with my base. So my base concentration, or the number of moles rather, I have left over is just 0.004375 minus 0.00075, which is 0.004. Oh, that's not quite right. Let me just do that calculation really quick. I was going to do it in my head, but let's just always double check. 4375 minus D3. Yep. So I'm glad I double checked that. That is 0.003625. And to get a concentration, we have to divide it by what our volume is. Well, I started with 25 mils of base. I just added 5 mils. So my volume is 0.03 liters. So let's take that divided by 0.03. So my concentration now is 0.121. We're going to do the same calculation for my conjugate acid, because basically when we add acid, we're making a buffer, right? That's why it's so important to write down the chemical equation always. If you don't write down the chemical equation, it's very hard to know what's going on. So I write down how many moles of my conjugate acid I have. The volume's the same. And so my concentration of conjugate acid, 0.025. Now I can use Henderson-Hasselbalch equation. pH equals pKa plus the log base divided by acid concentration. So I just got the base divided by acid concentration. I don't have a pKa, but I do have a Kb. And Kb times Ka equals Kw. So Kw is 1.0 times 10 to the minus 14th. Our Kb was 4.4 times 10 to the minus 4. So let me find out what my Ka is. So my Ka is 2.27 times 10 to the minus 11. But I want that as my pKa, not my Ka. So I just do minus log that. C5. Right. So my pKa is 10.64. So pH equals 10.64 plus the log of my base concentration, 0.121, divided by 0.025, which is my acid concentration. Log of 0.121 divided by 0.025. And my pK is 10.64. So my pH at this point is 11.32. So let's kind of think about, does that answer make sense, right? So at the very beginning of my titration, when I had nothing but base, my pH is 12.32. When I add acid, that drops to 11.32, which is a good thing. It should drop, right? As I add more acid, the pH will go lower and lower and lower. It should never go higher. All right. So that was C. Now D. What is the pH at the equivalency point? Right. So I'm going to erase all this stuff now. And my equivalency point was when I added 29.17 mils of acid. All right. And my pKa is 2.27 times 10 to the minus 11. So when I'm at the equivalency point, that means I've added enough HBr to completely react with my base, which means the only thing I have left is a weak acid, my CH3Na3+. That reacts with water. Now this is an acid, water is a base. So this will reform our base, and it will also form H3O+. So we have another ice table. All right. Oh, sorry, this is Ka, not pK. So Ka equals x squared divided by my concentration of acid. And so we have to figure that out, right? So let's go back to our calculation. I got to find out how many moles I have again. So remember, for the base, I started with 0.175 moles for 1 liter, times that by my volume. And so the amount of moles that I had in my base was 0.004375. Now at the equivalency point, that has all been converted to my conjugate acid because we have added enough HBr to completely react with my base, right? So that's how many moles of CH3Na3+ I have. But remember, for Kas, we need concentrations. So I need a volume. Well, I started with 25 mils. And to get to my equivalency point, I had to add 29.17 mils. And so doing that calculation, my concentration of acid is 0.8076. So I'm going to solve for X now. So I'm going to take that, multiply by my Ka. Then I'm going to square root that number. So X, which is my H3O+ concentration, X is 1.35 times 10 to the minus 6. That's H3O+. So I want to get pH, which is just minus log that. So my pH is 5.86. Or 5.87 by rounding. And again, we want to ask ourselves, does that make sense? And it should be below 7 because we have a weak acid in solution. And so the pH is below 7, so that's good. All right, pH at the 1/2 equivalency point. So this one's nice because if you're at the 1/2 equivalency point, pH equals pKa. All right, that's because when we do Henderson-Hasselbalch, base and acid are the same concentration at 1/2 the equivalency point. And that means the log of 1 is 0. So pH equals pKa, and the pKa was 10.64. All right, last one, pH after adding 5 mils of acid beyond the equivalency point. So for this, once we go past the equivalency point and we keep adding acid, we have that acid has no base to react with. So it's just going to react with water. So I need to find out what is the concentration of H3O+ now. So I need to know, okay, how much acid did I just add? How many moles? So my concentration is 0.150, and I just added 0.005 liters. So how many moles did I add? So I just added 0.00075, and that's actually a calculation we did in C. 0.00075 moles of acid was added. And again, I should show you the equation. You should always write down your equation. This is what's going on, H3O plus Br minus, because there's no base. Now my volume, oh, that was a bad line. Let me redraw that line. I need a concentration. So I started with 0.025 moles of base. I needed another 29.17 milliliters to get to my equivalency point. Then I just added another 5 milliliters. So this is a titration. So all the volumes are going to be additive like this. So my concentration of acid at this point, let me do that. My concentration of acid is 0.01 equals 0.0127 molar. And that's H3O plus. So I can just take the minus log of that. So the pH is 1.90, 1.897, and then rounding up. So again, we asked, does this make sense? We're just adding acid, so the pH should be low. And that's problem 2. So going on to problem 3, this time we have a strong base and a strong acid. So this one's actually a little bit easier than a weak base. So same idea. What's the initial pH? So let's write down. So a strong base dissociates completely. So Rb plus OH minus, right? So I need the concentration of OH by it's 0.115 moles for 1 liter, multiplied 0.025 liters. So what is our concentration of OH? So right now we have our OH constant. Sorry, I'm doing moles. I'm getting ahead of myself. This is our concentration of OH, 0.115. So let's do the minus log of that to get our POH. So our POH equals 0.939. So to get our pH, we just take 14 minus that. So our pH is 13.06. All right, so how much volume do I need to get the equivalency point? So Rb plus OH plus HCl makes H2O plus Rb plus H plus Cl minus. There we go. And so this is a 1-to-1 ratio. So I can do M1V1 equals M2V2 again. So I have 25 mils of my base. That's going to react with my acid, but I don't know the volume. All right. So 25 times 0.115 divided by 0.1. So the volume of acid I need is 28.75 mils. See, what's the pH if I only added 5 mils of acid? So again, like the previous one, I need to go to moles, and that's what I was doing up here. So let's go back to how many moles of base did I add? So do that calculation. And I added 0.002875 moles of base. How many moles of acid did I just add? 0.100 moles per liter multiplied by 0.005 liters. That should be 0.0005 moles. So of acid. So these two react completely. The acid's going to run out first. So let me do that calculation, which is 0.00237. So the amount of base I have left over is 0.002375 moles of base. And again, since I'm doing pH, I need concentration. So I started with 25 milliliters. I just added 5. So my total volume now is 30. So I'm going to divide that by my 30 milliliters. And my concentration of base is 0.07916. Remember, this is a strong base, so it's going to react completely. We don't have Henderson-Hasselbalch here. This is just my concentration of OH minus at this point. So I'm going to do the minus log of that to get POH. So POH is 1.10. We compared that to our previous POH and it's gone up. That's good, because that means our pH will go down. So 14 minus that. Our pH is 12.90. Again, we just asked ourselves, does that number make sense? And our pH is lower than what we started with, which it should be because we just added acid. All right, what's the pH at the equivalency point? This is easy. When you have strong acid, strong base, it's going to be 7. All right, what's the pH of adding 5 mils of acid beyond the equivalency point? Same idea as the previous problem. We have acid, and it's just reacting with water. There's no base to react with. So I need to know what's my concentration of acid. So I just added 5 mils, and we already did that. So I have 0.0005 moles of acid. And I have to divide that by my volume. I started with 25 milliliters. It took me 28.75 milliliters to get to the equivalency point. Then I went 5 milliliters over that. So my concentration of H3O plus, let me do that. My concentration of H3O plus then is 0.00851. Then I do the minus log of that to get pH. And my pH is 2.07. Again, since we're just adding acid and there's nothing to interact with it, I would expect it to be quite below 7, and it is 2.07. That's problem 3, a lot faster when you're using strong bases and acids. So question 4, it's the same as question 3 in that we have strong acid and bases, but we're doing the reverse now. We start with a strong acid and then we're titrating with base. So right now we just have HBr in solution. That's a strong acid. It's going to react with water, make H3O plus and Br minus. Reacts completely. So this is our concentration of H3O plus. So just do the minus log of this to get our pH. Right. And so pH is 0.757 right now. So very low, which it should be because we have nothing but acid in there. What is the amount of base needed to get to the equivalency point? So we need to check, is our ratio 1:1? HBr plus KOH makes H2O plus K plus Br minus. That's a balanced equation, 1:1. So I can do M1V1 equals M2V2. So I start with 35 mils multiplied by 0.175. That's my concentration of acid. equals my concentration of base is 0.2, and I don't know the volume. So I'm trying to figure that out. 35 times 0.175. Take that and divide it by 0.2. So the amount of base I need, this point is 30.625 milliliters. What's the pH of 10 mils of added base? So again, when we're not at the equilibrium point and we're adding base or acid, we need to go to moles, right? So how many moles of HBr did I start with? So let's do that first. 0.175 moles per 1 liter multiplied by 0.03 liters. Oops, 0.175 times 0.03. So the amount of moles of acid I have are 525 moles of acid. How about moles of base? How many moles of base do I add with 10 milliliters? So let's write down that KOH 0.200 moles for 1 liter multiplied by, I'm adding 10, 0.01. So I can do that one in my head. That's 0.0. Can I? I'm going to say 0.002. Let's just double check. Yep, 0.002. I could do it in my head, but I didn't have the confidence. That just shows you, you need to have confidence in yourself. So that's 0.002 moles of base. And these two are going to react and destroy each other. So that should be 0.00325 moles of acid left over. Yep. So the amount of HBr I have left over is 0.00325 moles of acid. I need the concentration because I'm going to do a pH. So divide that by my total volume. So 35, and I just added 10. So let's get a concentration. So my concentration of acid, 0.0722. Let's do minus log of that to get pH now. Right, my pH is 1.14. Again, my pH is going up because I just added base. And so now what is the pH of the equivalency point? 7. E. Okay, now I'm adding 5 mils of base past the equivalency point. What's the pH? So again, I need to find out how many moles I just added of base. And so that's half of 10. So that would be 0.001 moles of base. And sorry, I should always write down the chemical equation. The base, now all the acid's gone, so it's just going to interact with water, form OH minus plus K plus H2O. Right, so all the KOH I'm adding goes directly to OH minus. So my volume is, I started with 35 milliliters. It took me 3625 milliliters to get the equivalency point. Then I just added 5 mils more. So the concentration of OH oh, 625 plus 0.005. The OH concentration is 0.01416. So I'm going to do the minus log of that to get POH. P21. POH is 1.8. 1.85. And so my pH is just 14 minus that. My pH is 12.15. All right. So again, I'm just adding base at this point. So I would expect my pH to be well above 7, and it is. And so those are the different scenarios you will find are buffer problems. And again, as always, if you have questions, let me know. Otherwise, This is Dr. Andrews signing off, and I hope you all have a nice day.